All right, here's an example that involves a contingency table. So a postal carrier is delivering some mail. We've got letters, ads, and magazines, and we've got pieces of mail that are sent to homes and businesses. And this is the data that's collected for a certain day of mail delivery. So we're going to find some probabilities from this, but first I think it's beneficial to find all of our how manys. First I want to find out how many letters were sent. I'm going to add 325 and 732 to get that there were 1,057 pieces of mail that were letters. Doing the same thing to ads, we're going to add the 406 and 1,021 to get 1,427 pieces of mail that were ads. Doing the same thing for magazines, 203 and 97 give us 300 magazines sent this day. Well, now I want to find out how many pieces of mail were sent to homes. So I'm going to add the number of letters, 325, the ads, 406, and the magazines, 203. And this gives me 934 pieces of mail sent to homes this day. Same for businesses. We're going to add the 732 letters, the 1,021 ads, and the 97 magazines to get 1,850 pieces of mail sent to businesses. Now, if we want to find out how many pieces of mail were sent all together, we could add these these 6 values together, or we could add the number of letters, ads, and magazines. I'd like to do that. I'm going to add the 1,057, 1,427, and 300. And I get 2,784 pieces of mail. Oh, I accidentally erased a 0. That was my mistake. So if I add up the number of pieces of mail delivered to homes and businesses, the 934 pieces sent to homes, 1,850 sent to businesses, I'm going to add those up just to make sure that I get the same number of total pieces of mail of 2,784. It's like a check value. So 934 plus 1,850, and we do get 2,784 pieces of mail in total. This is our total pieces of mail. Now that we've got all of our how manys sorted, we can start finding some probabilities. Part A is, again, if an item of mail was selected at random, find the probability that the item went to a home. I'm going to go ahead and give some variables now. I'm going to say that home mail is an H, business mail is a B, letters L, ads A, and magazines M. Nice and easy, no repeat letters here. So part A, what they're asking for is the probability of H, the probability a piece of mail went to a home. So this is an individual probability. There were 934 pieces of mail that went to a home out of the 2,784 pieces in total. So 934 divided by 2,784. And when I put this in my calculator, it doesn't even let me reduce it, and that's fine. This is quite complex. I wouldn't expect a reduced fraction from this one. So a decimal rounded to 4 decimal places is pretty good. I'm going to say the probability a piece of mail went to a home is 0.3355. Be careful of that very last decimal place. It's rounding up there. So there's a 33.55% chance. That is the probability there. I like both of these, right? I like it in decimal form and in percentage form. Let's look at the next question. The probability the item was an ad or was sent to a business. The probability it was an ad or it was sent to a business. Now, whenever we have this A or B, quite perfectly in this situation, we have to ask ourselves if the variables are mutually exclusive. Because if it is possible that I could do both of these at once, then I'm going to be doubly counting on accident when I'm trying to find my probabilities. So if I think about, here we go. If I think about items of mail that could be ads or sent to a business, I know that this could happen at the same time. There are many pieces of mail that are ads and sent to businesses. In fact, there are, 1,021 of them, right? These are the ads that were sent to businesses. So I have to be careful when I go to do this probability. I have to take out that group that I'm counting twice. The actual formula is when they are not mutually exclusive, like what we have now, the probability of one of them, the probability it was an ad, plus the probability it went to a business, minus the probability it was an ad and it went to a business. So just think about it like this. Let's look at how many items were ads. We had 1,427 of them out of the 2,784. That's the probability of selecting an ad. The next part is the probability of selecting a piece of mail that went to a business. There are 1,850 of those, 1,850 pieces of mail that went to a business out of the 2,784. But we have to realize that when we're adding up the ads and those that went to a business, this group right here was counted twice. And that is this probability right here, the probability it was an ad and also went to a business. So we have to subtract out that repeating group. So I'm going to subtract out the 1,021 that I accidentally counted in both groups of ads and businesses. So let's do this. 1,427, 1,850. We're going to take out that 1021. And again, this is probably a pretty complex fraction. I wouldn't expect a reduced fraction here. Rounded decimal to 4 decimal places is good. 0.8103 or an 81.03% chance it was either an ad or it was sent to a business. Let's look back at this again. So the next part is, what is the probability the item, this is letter C now, what is the probability the item was a letter or a magazine? A letter or a magazine. So again, we do have the probability it was this or that. So we do need to ask ourselves, is this mutually exclusive? Could I take a piece of mail that was both a letter and a magazine? And in this case, no, this cannot happen. So we're not going to have to subtract out any repeats. There are no repeats. I'm going to just take the probability of selecting a letter plus the probability of selecting a magazine. Lordy, there we go. Because here are those that are letters, here are those that are magazines. There's no overlap, there's no doubly counting. So the probability a piece of mail was a letter, there's 1,057 of them out of the total group. And the probability of selecting a magazine, well, there's 300 of them out of the total group. And you should get 0.4874 or 48.74% chance. This doesn't get super exciting, so I'm going to change up this last letter. I'm going to make D this. What is the probability? Let's get rid of some of this highlighting. What is the probability of selecting a magazine given it went to a home? What is the probability of selecting a piece of mail that went to a home? No, that was a magazine. Ooh, dearie me, I almost did that backwards. Piece of mail that was a magazine given it went to a home. That means this H is my whole world. My whole world. Because I'm saying given it went to a home. That means I'm only caring about these 934 people right there. Well, pieces of mail, not people. They don't get delivered. These 934 pieces of mail are the only ones that I'm considering. And of those, I want to know how many are magazines. So the probability of selecting a magazine, given it was sent to a home, well, of those that were sent to homes, 203 of them are magazines. And the total that I'm considering here, just the ones that got sent to homes, so 934 pieces of mail. That is all I'm considering here. 0.2173 or 21.73% chance. 21.73% chance of selecting a magazine if we're looking at just the things that are being sent to homes. Well, I hope that was a pretty good overview of conditional probability. Let me know if you still have more questions about any part of this, and maybe I can do that a little more specifically.